You know, guys, I was thinking, this is my favorite class.
Let's go. I'm gonna rub that in Ben's face so much. Because he's like advanced chem's his favorite class.
No, advanced chem's only
That's not true. Advanced Chem's always my favorite class.
your favorite class, but not your favorite. Alright, go spend your time.
Alright, don't be offended. It's not like we're cool anyways.
I was coached last night, and I was like, yeah, I'm first. Do you know how early it was?
Dude,
Okay, when did you do this? I don't know.
me? You talking about me?
I was the whole time I was done, I was like,
Alright, guess what chapter we're on? We're chapter 13?
Light.
Okay, we're going to be dealing with light.
Let me guess.
Okay, this is actually, I enjoy this chapter far more than I enjoy chapter 12. Sound just kind of bores me.
Same.
Yeah, I just think the sound comes in your mouth right now.
I understand. And I understand that students think physics bores them. And that's fine. I don't expect you to like every little thing that I try to like.
Cranes, that's what I aspire to be.
Me?
A crane.
Oh, me? I'm a crane.
So you're too hard. There's only one way to make that happen, right?
You desire to be that. Alright.
Don't make it be.
So,
Not what I make
Take me.
when most people think of light, they're pretty narrow-minded. Why do I say that? Any ideas?
Because they don't watch Star Wars.
Serious question. When most people think of light, they're pretty narrow-minded.
They think of this.
Think of this stuff.
Yeah, it's me.
They think of the visible light, but that's like 1/10 of all light forms.
There's unvisible light.
Oh yes.
You know?
Have you ever had an X-ray?
Yeah, I didn't.
That's light.
X-ray.
Microwave?
Have you ever had an X-ray?
Oh, radio.
It's light.
Microwave
Have you
radiation.
ever used a microwave?
Yeah.
Yeah.
That's light.
Well, yeah, there's no light.
Is that light or
Is
radiation?
that what you're talking about?
No.
It's electromagnetic
That's
wave,
light.
which is a light wave.
Do you know what X-ray
Light
is?
is like.
Have you ever heard of ultraviolet light?
Visible light.
Oh, yeah, the sun.
Yeah.
UV rays.
That's light.
Well, yeah, because that's what the sun is. It's light, right?
Okay. UV light, how about, there's a lot of different light forms. Okay? Jesus is another light form, yes, very much. Okay? If I were to take white light, and I were to put a fluorescent screen that was green and shine white light through the green screen, you would see green light come out of it.
Sir, really?
Okay? Yeah.
Why?
Because what color is all based on what light is reflected back at your eyes. So for example, when light hits that black object back there, no light comes back to your eyes, and that's why it looks black.
There's a darker
Because-
shadow though.
Because all the light gets absorbed onto the black material, and none of it gets reflected into your eyes. Okay? So when I look at Cole, the light comes up, hits Cole's red sweatshirt, most of the wavelengths of light get absorbed, but the red wavelength gets reflected back to my eye, and that's why when I look at Cole, I see red.
You see red when you look at me? Are you saying you're mad at me?
Okay? So,
Darkness.
when we think of light, we think of white light, or typical visible light. But even our visible light can be broken up into various different colors of light that you guys probably are familiar with.
Isn't green
Roy
red and light?
G. Biv.
Oh.
Roy
I was gonna say
G.
rainbow.
What's Roy G. Biv?
Red, orange, yellow,
Red,
green,
right,
blue,
okay.
indigo.
So I could pull a prism out, and you guys have probably seen a prism before.
Pink Floyd.
Okay, when white light goes through a prism, it scatters the light into its various wavelength forms. So yes, we are still going to be talking about some very typical things that we've. Wow.
I got you.
All right. Yeah. Cool.
That's a rose.
Oh yeah. Oh, I'm not ready for that. I was shocked.
Do I have this?
Oh.
Hold
Wow.
So, what light is a type of electromagnetic
Oh, it's
radiation.
radiation, Avery.
Okay? So yeah, it is a radiation. Okay, so an electromagnetic wave, this is really kind of complicated. It's not a simple definition here. It's an oscillating electric and magnetic field. Okay? So essentially, I'm not going to get too crazy deep into what an oscillating electric and magnetic field is, because it's pretty high level. But basically, it's an electric field creates a magnetic field, which creates an electric field, and that's what propels light through the air. That is why light doesn't need a medium to go through it, because it has the electric and magnetic field that's causing it to move through. It doesn't have to pass through a medium like what does? Sound. Okay? This is why you can't hear sound in outer space, but you can see what?
Light.
Light. That's why sunlight can come to Earth.
Oh, wow.
The electromagnetic spectrum includes. I pulled that out of my pocket? That's so tragic. Okay. The electromagnetic spectrum includes more than visible light, and I think your book, I'm going to check. No. Your book probably has the spectrum. We don't look at the book, blah, 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 blah.
Remember how last time we were
Terrible for you.
443?
Found it, 443? Get there, 443! Pronto! March! Vámonos! You say
Yep.
March.
Nice.
You got a book, open it up! Sasquatch?
What?
Well, I might be an insult to it.
I wasn't talking about you. If I was talking about you, I'd use a different word.
Oh!
Sexy.
Sexy humble-beast. That's exactly what we're talking about.
No.
Thank you. Jesse, are you okay?
Make it stop.
Are you okay?
Yeah, what?
Lauren, you not have a book?
Why am I offending you, Lauren? Okay. So on here you can see all the types of electromagnetic spectrum. Okay, we got radio waves, microwaves, IR waves, visible light, UV light, X-rays, gamma rays.
Emma.
Okay, so what you're essentially doing with a microwave is you're shooting light into your food. It's transferring energy to the water molecules in your food via vibration, and therefore your food heats up.
Oh, wait.
You know fruit flies
So
won't die.
microwaves don't even have microwaves?
Because they don't have water in them?
Small.
Yeah, they do. That's what
what
transfers the heat.
It says microwave ovens right there.
What? Fruit flies are
Well, right, but I feel like
It's waves of light into your food.
Is that like crumbs?
Oh, microwave, microwave. Yeah.
That's awesome. Okay, so let's just make a practical look at this. You can see your radio waves. You're very familiar with radio waves. That's actually what televisions transmit their signals through, is through radio waves. Okay. Microwaves, what do you use microwaves for? Well, there's a lot of things that you can use microwaves for. You're probably most familiar with microwaving your food, but it's used a lot when you're doing research. And then you've got IR waves. Physical therapy. I think IR waves are like when you do, what's that called? Where they like rub that like metal object on you. What? Ultrasound.
Oh.
Isn't
That's a
that
metal object.
Isn't that sound?
Yeah, you said it was sound.
Ultrasound?
Yeah.
They use sound.
Because they say sound.
No, they use sound. It's
Okay, I don't know. Maybe I'm thinking about something else then. Okay? Or maybe I just trying to make one. Anyway, okay. UV light used to sterilize because it kills bacteria. It'll kill you too if you have enough of it.
Are you calling us bacteria?
Oh, we are bunch.
You fill in the line.
How do you use light to sterilize?
X-rays. Okay, you know what the purpose of X-rays are. There's quite a few of them. Gamma rays, you don't want to get anywhere near that. Okay? Yeah, it's funny that we just basically shoot death at our bodies.
When we're already on.
Well, it's basically like
Emma.
You basically kill everything, and you're hoping you get cancer with it. And hoping you can survive, basically going through torture. Okay, so if you look at these, you can see the frequency and the wavelength. We're not getting away from frequency and wavelength. Light still is a sine wave. Okay, so you're still going to have your frequency, you're still going to have your wavelength. What you'll find is radio waves are going to be on one end of the spectrum, and gamma rays are going to be at the other end of the spectrum. What I mean by that is radio waves have a really long wavelength and really small frequency, okay? And gamma rays are the opposite, because we know that frequency and wavelength are inversely related. You've got a high frequency, you have a long wavelength. Okay? So, oh shoot, it's on. Ah!
Yes.
Are we done? We're done.
Amen. Oh no.
Hey, guess what? We already showed you this equation.
Yay, let's
Yeah,
go.
we did.
You see. We don't even know.
Oh,
We
yeah.
use B technically, but then I replaced it with C because I like C better. Okay? So same relationship. Speed of light is this. I think the reason why it wasn't C last chapter is because waves aren't always a constant speed. Light is always a constant
I
speed.
thought it was like not 3 points.
It's like 2.997.
Okay.
Yeah.
Actually, not when you shoot it through absolute zero substances.
I didn't know you could get to absolute zero.
Well, near absolute
Okay.
zero substances.
That makes. Well, that's
It's
interesting.
slow, like if you shoot a laser through it, it'll slow it down.
Huh.
So if I shoot them,
I'm wondering why that is. Because it doesn't allow the electromagnetic field to oscillate as fast? Or why?
If you turn your headlights on, moving it to the speed of light, what will happen?
You turn your headlights on, moving at the speed of light.
Yeah.
You're in your car moving at the speed
Yeah,
of light.
when you turn the headlights on.
You'd be moving with the light.
So you wouldn't have any light.
Yeah, probably not. Yeah. Okay. So here's your equation. This should make sense. Your electromagnetic waves vary depending on frequency and wavelength. And since all electromagnetic waves have this speed, okay, all of them travel at that speed. So whether it's a radio wave, whether it's a microwave, whether it's a UV wave, whether it is your distraction wave.
A distraction
Yep.
What has
Yeah, that's a typo.
That's what I said.
Should be down. Alright. I don't know if I can. Let's.
Space.
No way. Who would have thought?
That's true. My grade is also approved. It's not playing space.
Well, that means you can never play space. Alright, so. Alright. You ready?
I am ready.
In classical electromagnetic wave theory, light is a wave composed of oscillating electric and magnetic fields. These fields are perpendicular to the direction in
What
which
kind of wave is
the wave
it?
moves.
Sine wave!
Fine. You
Therefore,
Perpendicular.
electromagnetic waves are transverse waves.
Transverse.
The electric and magnetic fields are also at right angles to each other.
So that was just really basically to get you guys to come up with the fact that waves are, these types of waves are transverse, which, is that not in your notes anywhere?
I mean, you think light is
Okay, you guys are gonna wanna write somewhere in your notes that, your your light waves are transverse waves, which means that it oscillates perpendicular to the wave motion. So oscillates up and down, side to side, perpendicular to the fact that it's moving through space. The wave motion. Yep. Alright, I'm gonna say some things here that you're all gonna be like, duh, but bear with me. Okay, experience has probably shown you that it's easier to read a book when you're close to a lamp that has 100 watt light bulb in it versus a 25 watt light bulb, yeah? Experience has probably shown you that when you're reading a book near a lamp with a 100 watt light bulb, it's a lot easier to read it than when you sit next to a lamp that has a 25 watt light bulb. Duh, right? Never done that. Never compared. Have you ever noticed the difference between a higher wattage light bulb and a lower wattage light bulb?
I like that.
That's essentially.
Like 10 watts.
That's essentially what I'm saying. Okay, here's another duh question. You guys have probably also experienced that it's easier to read a book closer to the light than further away from the light.
Oh my land.
Duh, right?
Duh.
Okay. Well, believe it or not, there's two things we have to take into consideration. We have to take in watts, which is the power, but we also got to take in this little idea called lumen. You ever heard of a lumen?
I have heard of
A woman.
Yes, lumen.
A woman?
one of those.
What's a woman?
Is that I say anything and you immediately think woman or what?
Yeah.
Avery Bush. Okay, luminance. Okay. Yes, luminance. What this idea is that when you turn on a light bulb can only emit so much energy. Make sense? Like depending upon the type of light bulb you have, whether you have a 20 watt light bulb, 100 watt light bulb, it can only emit whatever that particular light bulb is capable of emitting. Okay? Well, over time that light gets away from the source, correct? Okay?
Yeah.
So essentially what you're doing is that energy that was emitted gets watered down as the distance what? Increases.
Intensity.
Okay? And this, I'm trying to put stuff in my pocket. And this is why we can say duh to the statement that when you're further away from a lamp, it's harder to read than when you're right next to a lamp. It just simply has to do with you're taking the same amount of energy and you're watering it down over distance, and so therefore you're not going to have the bright light as you get further away from the light source. What? Yep, and this is what this is trying to show. This is the same light source, and it's brighter the closer you are because that is the same amount of energy over a small area versus here you still have the same amount of energy but you've essentially dissipated it over a larger area and so it doesn't appear as bright. What is so funny? So,
Example.
let's do a really easy example that you can probably do without my help. Go.
Do it.
Yeah, John, you have 4 minutes work on Gopher project.
Literally not how it calculated.
We can get our track on.
That's literally.
Any radio bands, extends, blah, blah. What are the longest and shortest wavelengths?
Yeah, I know.
You're lost.
UC.
Do you know what a wavelength is?
It gave us 2 frequencies.
Okay, because it wants the longest and the shortest wavelength. So you're solving for 2 things.
Guess who's taking
Kind of
my
bugs me to read that instead of like.
You have battery.
Do I have a pencil? You came to class without a pencil?
One way you scratch fire.
The nub. Why would that?
Are you guys still struggling over there, or you figured it
Is it
out?
just 2 answers?
Just 2 answers.
Okay, that's what I
Okay, and it should make sense that the lower frequency will give you the higher what? Wavelength.
think.
Yeah.
I don't know why, but.
Wait,
wait,
on
I
which
know.
chapter?
Why?
Oh, wait a minute.
I just said wavelength because that was the only other thing we were saying.
There's a certain
Wait, does wavelength have a unit?
frequency, high
High frequency, low wavelength.
frequency,
No, that's high wavelength. That's
Got
low
it,
wavelength.
okay.
and this is lower frequency, or lower wavelength.
See a run? I think more.
This is longer wavelength, shorter frequency. Yeah, okay. You remember that? Remember that? Well, I'm just trying to show you that the number up there that has the lower frequency should give you the longer or the larger wavelength.
Why? Oh, this is the frequency of the light. So the longer.
It just means that it's sine wave.
Yeah.
Except it's more elongated.
Kramer.
I feel like we should tighten this a little bit because it keeps freaking to not go any further. It won't stay. Oh, there it goes.
Okay?
Shorter, what'd you say, the shorter wavelength, my shorter has a shorter wavelength.
Shorter wavelength gave you a short, short frequency gave you a short wavelength?
Go into the tuner and pull out.
What do you mean? Did you guys get, did you guys get 5.6 times 10 to the second and 1.8 times 10 to the
We'll have
second?
to
Yes.
the cardboard down a little bit.
So the shorter you hold on to it, the smaller the frequency, the bigger the wave.
Go down real hard.
I'm showing everybody my ball.
No, I forgot.
That's okay, I'll bring the card. 555.
Don't put the I put that on mine.
Because, look,
So
I inherited with how I
smaller, the fire back up.
was the shorter.
Like traffic, you can't allow to show it.
Are we not putting the cardboard?
Higher risk, or
Wait, I'll watch on that.
Are we trying?
Smell this.
Cranes, we're doing it.
You're doing it, right?
I guess. Wait, this has to go first.
Wait,
Oh my word, it's a hippie band. Is that the one of the cars?
Yeah, it is.
Why are those blocks?
Alright, let's see it.
I don't know. Oh.
Whoa.
Oh! I was just about to say my words. I like how little.
Wow, that's gonna make a mess.
No, Crane.
But you better back up. I'm
We
just
have
staring-
carpet. We have carpet.
We hold towels.
Yeah, that's what we do, and we grab it. We have carpet. You guys have carpet. Oh, I didn't put this back. It didn't even make a mess.
right in my eye.
Yeah, me too. It's all my face.
Oh, I thought for I was like, holy cow.
Good.
I thought for a second you would have that block there and it was gonna go right through the table. I seriously was
I
like,
thought of that.
I was thinking in my head, I was like, oh boy. And then I looked, I was like, okay.
Oh, it's an old guitar.
Oh, I got right. I shot directly in my eye.
Everything there's
That was awesome.
11 machines.
No, it doesn't. Ours doesn't. Ours just like 5 parts.
Nice. I thought like having like 10 machines would be so much more. But it takes like 10 seconds. Yeah, ours took. Yeah, it was like.
What is Emma? What is this?
It's a Last Airbender staff. It's one of my brothers.
Oh, we need it.
Well, you can go down there and this.
Emma, what are all these things? Are these pulleys?
Yeah, or it counts as 1 pulley, 2 pulley. Yeah, pulley.
Wow, that's
1 pulley, 2 pulley. This was our original, and then it got switched up major time. Because then we found out we.
Alright, I need you guys to leave on time today because I have to get set up for a lab. So,
Daddy.
thank you. Okay, we'll test it.
That's the hard part.
We're about to get wet. Look at all the chisel marks.
On my elbow.
Chisel, chisel, chisel.
That's how many times it's been successful. 5 times.
Oh,
Well, I've
Oh, I
only,
thought you used a lot more cans than that already.
no. I've only smashed 2 cans, but I've also had it drunk. It won't. I mean, it's so the grain won't.
Wait, does that count as a wet?
Alright, quickly,
Yeah, 'cause it
please,
should.
Because it's like
guys,
wedging
thank you.
it in half.
All Mrs. Stafford has to see is Crossway 2010 and then a biblical reference and she's like, no.
That's a good run.
Also, I wrote this whole thing on my phone, so it's not spelled, but it's amazing.
3 days.
Emma, come on. My book, as of right now, took me 20 minutes to do last night.
Yeah, can I have a pop?
No, we're going to your dad's room.
I was only supposed to bring a tree, but I didn't want to carry it.
He runs over Kate.
We need to go to class now.
Where do I sit?
Oh.
No, yeah, one time you're playing in the car and yet your friends keep drinking in the car.
Don't sit, just stand.
Oh my God.
What if it was like all the way around?
And Nora, I don't know.
Graham, what the heck?
We're
we do,
standing.
dude?
Just stand quietly.
We're not going around.
Actually, you don't even need to, go put your books away.
Hey, man, Graham.
Are we just?
Go put your books away, you don't need them.
We're quite silent.
Less stuff in here, the better.
We're not keeping back.
What would science be like without?
You don't need your backpacks, you don't need your books.
What would it
I keep my back all sorts of fun stuff. We don't have to do anything. We don't bring our backpacks in either.
So no homework?
Nope.
Nothing. Put your phone. Bring your phones.
喝了啊，
你现在上代数了。
喝了啊，这样
我今天上代数了。
Alright, you don't need your books, you don't need your bags. Leave them out there.
喝饱，回家了。
You don't need your food, you don't need anything.
We're doing a lab?
Yeah, go put your backpacks in your locker.
Put it away.
You will need a pencil.
Laura, you told me
You will need a pencil.
Laura, you told us nothing.
Sorry.
After class, how about that? Alright, who are we missing? Okay, since I don't have you guys seated, I don't know if we're missing anybody. Could you help me out if we're missing anybody? Okay, here's what I'm gonna do. Unfortunately, we have a big class, which stinks, because we only have 3 lab stations, so we'll have to deal with that issue. One, that's it?
It isn't, because we're on Instagram.
Yeah, I read it. It's a bogus article.
I will think that's my favorite.
Alright, so here's what we're gonna do. Let's see here. Alright. I know, I put them on there. Okay, let's see. Your group 1, group 1, group 1, group 1, 4, group 1, group 1, group 1. Over here. Group 2. U4. And actually we'll go and U3.
So all of us.
Yep.
Except for Rose.
And then you guys are all in a group.
Yes.
Why don't we just
Okay. You would help translate maybe for the rest of here? Yes, if you can. Okay, here's what we're gonna do. Okay? We're gonna do a lab today, which I need to give you. Where is it? Here it is.
Yay.
There you go.
That's a lot of paper.
There you go. There you go. And first off, you're dealing with with thousands of dollars worth of equipment, so if you screw around, I will literally kick you out. I don't want to do that. So please don't mess around. There you go. There you go. There you go. There you go. Okay, so here you go.
Kramer, do you want to start our names on these?
Sure. It is your homework. There you go. There you go. There you go. Okay, so here's what we're gonna do. I want you guys to step away from the board.
Over here.
Sure. Okay. So everyone, please focus and pay attention while I explain what you're going to be doing, because this is a large group. I do not want to have to explain myself 7, 8, 9 times. Okay? Procedure 1. And we're going to take 2 days to do this. Okay? I've already done number 1 for you. So go ahead and put a little slash through number 1. Okay? Now, you guys aren't super familiar working with these things. These are called lab quests, and you can see on the board what I'm doing. So you should be up, turned around, looking at the board. You shouldn't have your back to me at all. Okay? I'll just quickly get rid of this here. So this is the home screen that you will see. Okay? At the top, there are different tabs. This is your home screen. This is going to be your graph tab. This is your table tab. This is notes. You won't ever deal with these two at all. These 2 tabs, well, these 3 tabs are probably the most common that you're going to use. So if I click the graph tab, you're going to see a graph pull up. And there's a lot of options. You can actually click File, Graph, Analyze, and I'll just show you quickly what that looks like. If I click Graph, it pulls down a bunch of options. If I click Analyze, it pulls down a bunch of options, and so forth. Okay? That's what the data table would look like. Currently, it has no data in there because we haven't done anything. Make sense? Yeah. Okay? Then, it says in number 2, it says on the meter screen, that's the home screen, that's this. It says tap duration. Anybody see it?
Yeah.
Got a little stylus, all of them have a little stylus. You're going to come over here, you're going to tap the duration, you're going to change it accordingly. I'm not going to say any more about that. I'll let you deal with that. Page. Okay? Reading is something you're going to have to do. Okay, number 3, it says you're going to explore a position versus time graph. So, I will do that. Okay? This is a position versus time. So you are going to study how a graph looks when you change positions over time. So like when I go from here to here, what does that look like on a math graph? Okay? We will do velocity versus time tomorrow, a more complicated graph. This is ACT 101. You want to get a good science ACT score? You need to understand graphical analysis. Okay? Because there's really 2 forms of science. There's content, and then there's application. And what's interesting is colleges want content, but ACT wants application. Kind of stinks. The world we live in. Okay? It says, take a starting position approximately 0.5 meters or 1 meter away from the motion detector. And I have written on the ground how far you are away. This is what's called a motion detector. So if I go back to the home screen, I can figure out exactly how far I am away. Come on. It's changing on here, but not on there. Did I lose my connection? That's weird. Fine. Oh, there we go. Okay, so if I stand in front of it, it tells me how far away I am from it. If I step back, I should get further away. If I step back, I should get further away, and so forth. You see it. Now, these work with sonar. It pushes out waves in a cone shape. So if you're in the way while someone's doing their motion, it's gonna mess everything up. Okay, so stay out of the way first and foremost. Okay, then it says you're going to signal your partner to start data collection. Where the start data collection is this little green arrow, you push it and it starts it. You will hear a bunch of clicking. That's when it's starting to do the reading. Okay? And it says that in C. You're going to walk a distance of 3 meters and stop. You're basically going to see what does it look like when I go from 1 meter to 3 meters on a graph. Okay? You're going to do, in step 4, you're going to do the same thing, but you're going to do it a little quicker. Now, only one person needs to do this for everybody to see what the graph's going to look like. Because what you're going to do, which is going to be fun, hopefully, but for some of you, and early on, you guys will completely butcher it. But that's okay. And I'll show you what I mean. Eventually, what you will do, and this is what number 5 is telling you, is you're each going to do a match position versus time graph. It says, go to analyze, blah, 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 go to motion match, new position. Okay? So what you are going to do, each person individually is going to do their own motion graph, or position graph. What I mean by this is each of you are going to get a new position graph, and you're going to try to mimic the position that states. Everybody understand what I mean? You're going to try to move your body with the thing to try to get it to match that. So what that means is you're going to maybe have to work with your group to kind of come up with a game plan. Where would you start if you were trying to match this motion graph? About, so this would be 1 meter, so a little less than 1.5. Good starting point, right? Now, am I getting closer or further away from the motion detector? I'm getting closer because my position's getting what? Yeah, it's getting lower, right? If I start at 1.4 meters, I'm going down, so I'm getting closer to it. Then I stop and turn directions quickly, and I speed up. All right, it's going to be a fun little guy to do. So I'm just going to show you, I'm not actually going to try to do this, but I'll just show you an example of what it's going to look like. Let's say, I go like this, and I kind of go like this. I did it too fast. Oops. Thank you. So obviously I butchered it. Okay, you will too. However, I'm hoping that you will get good at being able to predict. Now remember, this is over time. Does this make sense? So let me ask you, from here to here versus here to here, which one am I walking faster? The last one. Because I'm covering more position over a certain time. That's something you gotta take into consideration. And if you think you can not pay attention in this lab and tomorrow's lab and be okay on a test, you're wrong, because I'm going to make you analyze graphs on a test. Okay? Questions? All right. Here's what I will say. Each of you needs to do this in your group. So all 7 of you are going to have to do your own one. Not the same one, a different one. And so to get a different one, you're just going to do the exact same thing. You're going to go to your analyze, motion match, and just get a new position graph. Some of them will be harder than others. That's okay. Plan with your group to figure out, okay, what am I going to do? Am I going to move forward? Am I going to move back? Am I going to do a little bit of both? Am I going to go fast? Am I going to go slow? Plan it out. Okay? Then, in the processing the data, part A, this is what you've got to be doing. Okay? For number 1, it doesn't say, I think it says in your procedure somewhere, you are going to draw your graph. So let's say Carly did this graph, and this is what hers looked like. It was actually, really good. Something like that. She will draw her graph here with both lines. The line that she was trying to match and what her actual motion looks like. Okay? Now, hers is going to look different than Sydney's. Because why? Because you're going to use a different graph. So each of you will have a different graph on your sheet. That's specifically for you. Does that make sense? Okay? And then in number 2 it says, what did you have to do the match to graph? It probably should say, what should you have done to match it better? Okay? Because you're probably not going to get it perfect. Fair enough to say that. Okay? And then the third one you all can do on your own. We will stop at part B, velocity, and we will do that tomorrow.
Any questions?
All right. Find a station. We need to move these desks a little bit. A little bit. Okay. You guys, here. Here's your.
Everybody that's in here.
I'm not a man of physics. I am a man of
Ask questions about where.
I'm gonna be good at that.
Okay. I need to plug this.
I realize I'm forgetting I'm
I'll get that for you.
Whoa.
Hey, but you guys need to be engaged. Don't let one person do it all. Okay? If you have questions, I'd rather you ask me than just do something stupid.
Okay.
Make sure when you're doing the motion, you guys gotta get out of the way, because you will be in the way of how that works.
Cool.
You can stand there when someone does it.
Everybody else does it. So you're starting at like 1.4.
Everything's already done.
There's a lot.
2 and 3. You gotta follow the procedure. Did you already do that? Okay. So get rid of that. We'll analyze number
More data collection from position versus time.
motion that. Okay, so the tab there. Duration. You guys do we have to do?
Calculation and change to try to figure out time.
So you change the duration.
Yeah.
Second, okay. You should be watching. I'm sitting doing nothing.
Everybody else is away from
You did? Alright, get number 3.
I didn't cut it.
I'm sorry, I was like,
Well, you only close the back.
Do we have some new students here or what?
You're moving from go back out
You guys need to be engaged.
I'm gonna take my papers.
Oh, more data
Find somebody. I'm Vernon, I don't care. Okay, stand at that position. Okay, then what does it say? Single G of Vernon to start data collection. What did I say that was? Bottom left corner, little play button.
You're just gonna, okay, so when, wait for the velocity and then go up to the 3 meters and stop.
Look at this. Like what you thought it would look like.
然后刚才不到位置。
How big is the cone?
Pretty fast. That's fine. Okay? Look at it, discuss. Does that look what your eye wants?
Okay, so.
Maybe your second one goes slower and see what.
So that's fine, open it.
So, yeah.
And this one, the one on top.
They don't want to do Let's see what it looks like.
Okay, guys, now we're gonna do, we're gonna try to.
Try to make sure you stay in
Probably heater-ish. And then we're gonna stay.
I would rather do it out and then, because then you're just watching it all. I want you to plan it out best you can. Remember, don't do it in a second. Give them a few, but don't take too much. Okay? Start it like, okay, in my head, I'm gonna take 3 seconds to walk back to this. Take 2 seconds to walk to this point. Then I gotta take 1 second to walk to 13. Does that make sense?
所以人一流是个高功率灯泡，是吧？
他们3个合起来9口一个，
不是，是你和那个你和没有说也不是，然后人家就